Hello everybody, myself Jyoti, and today we are talking about basic properties of neutrinos, photons and mesons. Basic properties of neutrinos. First is they have zero charge, spin is half, rest mass is 0, magnetic moment is smaller than 10 raised to minus 8 Bohr magneton, or it is nearly 0, and these neutrinos, they have energy and momentum. Now, how antineutrino, antiparticle of neutrino, that is different from neutrino. So neutrino, it has an antiparticle which is called as antineutrino, and it differs with respect to a property, and that is known as helicity. Helicity, basically it is the handedness. So this value of H, helicity, it is +1 for antineutrino, and this helicity value is -1 for neutrino. So that is how, depending upon the value of helicity, we can differentiate between antineutrino and neutrino. Now let us come to photons. So basic properties of photons are: spin is 1, it has no rest mass, no electric charge, and spin of the photon, it is associated with its polarization. So if we talk about antiphoton, how antiphoton differs from a photon. So we have left and right circularly polarized light, which corresponds to opposite senses of rotation of the photon, and depending upon whether a photon it is left circularly polarized or right circularly polarized, we call them as antiparticles of each other. So photon, it differs from antiphoton in terms of what we call as whether it is left circularly polarized or right circularly polarized. Now let us talk about mesons. Mesons are intermediate particles. That means they have the mass heavier than electron but lighter than proton. So mass of meson, it lies between the mass of proton and mass of electron. Now these mesons, they carry either positive or negative charge, and they were named as mesotrons by Anderson. Later on, the name was changed to meson from mesotron by Indian physicist Homi Bhabha. The existence of this meson, this particle meson, it had been predicted by Japanese physicist Yukawa in 1945, and he predicted the mass of this meson approximately of the order of 200 to 300 times mass of electron. What are muons? So Powel, Occhialini and others showed that we have actually two different kinds of mesons with different names. One with different masses. So one having mass of the order of 300 MeV, and another one lighter, which is having mass of the order of 200 MeV. The meson which is heavier, that means which is having mass of the order of 300 MeV, that is called as a pi-meson, and lighter one, it is called as a mu-meson. Now according to new definition of mesons, the mesons are the particles with spin 0 or integral. As mu-mesons, they have spin half, they are commonly referred to as muons, and pi-mesons, they are commonly referred to as pions. Pi-mesons are 100 times more stable than muons, and they are heavier too. So these are the basic properties of photons, neutrinos and mesons. So thank you so much.